All right, in this video, I'm going to go over 3 different theorems. I know it's a lot of writing, a lot of words, but again, make sure you check out the key on Canvas to make sure you have all of these notes. And all 3 of these theorems are actually on the theorem/formula sheet. So nothing you need to memorize. Obviously, we'll be using them a lot, so you'll probably hopefully feel pretty comfortable. So I'll kind of briefly work through each of them. So the first one is the segments of chords theorem. You can see here that if I have my chords A, B, and chords D, C, all right, if they intersect on the interior of the circle, all right, then I can say that each segment of the chord multiplied together, so the product of those two will be equal to the product of the other 2 segments of the other chords. So you can see here I have EA times EB equals EC times ED. We'll be using that very soon. The segments of secants theorem, you can see we have 2 secants, and they are they share an exterior point, right? That vertex E, right? The way we can say for this one is that if you look at those secants, that the relationship is if I look at EC, that's what my brain sees first, EC times the entire secant ED is equal to that external piece EA times the entire segment EB. So that's the segments of secants theorem. And finally, the segments of secants and tangents theorem. So we have 1 secant, 1 tangent, very similar to the one above it. But I have EC times ED, so that small exterior or external segment times the entire segment is equal to that tangent EA squared. All right, so it times itself. All right, so let's use these in 6 questions. All right, so this first one. It says to solve for x. This is the very first one with our chords intersecting in the interior of the circle. So I'm going to write 10 times x equals 14 times 15. So 10x equals, well, 15 times 15 is 225. Take away a 15, you get 210. So x equals 21. Okay, so that is it for the first one, just solving for x. Number 2. Find segment BD. Very similar to the one we just did, but this time I have 4 times 5x minus 1, so an expression, equals 6 times 6. So distributing, I get 20x minus 4 equals 36. Move that minus 4 over with addition, and you get 40, so x is 2. Now this one doesn't say to solve for x. It says to find the length of segment BD. So BD is equal to 4 plus 5x minus 1. All right, so what I'm going to do is I'm going to plug in where it says x. I'm going to plug in that 2. All right, and that's going to give me 4 plus 10 minus 1, which is equal to 13. So BD is equal to 13. Okay, number 3. Now I'm moving to a new theorem. This is the secants one, the middle one here, where they're both secants, the segments of secants theorem. So for this one, I am going to, the way I think of it is this small segment times the entire segment is equal to this small segment times the entire segment. Okay, so watch how I do that. So I'm going to write 8 times 8 plus 3x plus 4 equals 7 times 7 plus 5x plus 2. Okay, so now I'm going to clean up that stuff in the parentheses. So 8 plus 3x plus 4 is going to be 3x plus 12. This one is going to be 7 times 5x plus 9. I'm going to distribute. You get 24x plus that is going to be 96 equals 35x plus 63. I'm going to move the 24x to the other side with subtraction to get 11x. And then move the 63 to the other side with subtraction. 96 minus 63 is going to be 33. So x equals 3. All right, and so this one just said to solve for x, so I'm finished with that. Okay, very similar one here, using that same segments of secants theorem. But this time it does want me to go a step farther and find a segment MN. So I'm going to do 10 times 10 plus 8 equals 9 times 9 plus 2x minus 7. So that's going to be 10 times 18 equals 9 times, getting like terms here, 2x plus 2. All right, if you wanted to, you could. I see an 18 and a 9 on opposite sides. If you wanted to make the number smaller, you could go ahead and move the 9 over division. All right, that's absolutely totally fine. I'll go ahead and just distribute straight up to keep it the same way I've been doing it, but please feel free, if you recognize that, and especially without a calculator, it will make your life easier. Equals 18x plus 18. I'm going to move the 18 over with subtraction to get 162. And I believe this is going to be 9. 10 times 18 is 180. So take 18 away, gets 162. So yes, x equals 9. Now that's not done, right? I need to find mn, right? I need to find this segment here, which is the same as 2x minus 7. So I'm going to plug in, where it says x, I'm going to plug in 9 to get 18 minus 7. Make that 8 a little nicer, which is equal to 11. So segment MN is equal to 11 units. All right, last two. All right, and this is our last theorem that we had in the first page. We had the segments of secant and tangent theorem. So this one here, I'm going to write 3x squared, right? So that tangent, you're going to square it, equals 9 times 9 plus 16. So that's going to be 9x squared equals 9 times 25. I went ahead and just did not multiply the 9 times the 25 because I noticed I have a 9 on this side and a 9 on this side, so those will cross out. So I just have x squared equals 25 or x equals 5. Just solving for x here. I went ahead and I only used the positive one, so I can't have a negative segment length, so we're just going to do positive 5 for x. Okay, last one. All right, same thing here. I'm going to write 15 squared, that's my tangent, squared, equals 9 times 9 plus 3x plus 1. All right, this is 225. This is 9 times. So combining like terms, I get 3x plus 10. All right, I'm going to distribute to get 27x plus 90. So 27x equals, if I move that 90 over, 100 would be 125, so 90 would be 135. And x is going to be equal to, let's see, I believe that's going to be 5. Confirm. 30 times 5 would be 150. Take away 15 gives me 135. Awesome, perfect. So x is 5. Now, not done. I need to find AC, right? AC, this whole thing, is equal to 9 plus 3x plus 1. So plugging in, you get 9 plus 3 times 5 plus 1. And that's going to be AC equals 9 plus 15 plus 1, which is equal to 25. So AC is 25 units. All right, guys, that's it for this video. I have more practice problems, which are not done in this video, but I will do them here in a moment. So check out the key on Canvas to look at the answers to those next 4. All right, come see us if you have any questions.